For our first interpreter, we'll evaluate a little expression of arithmetic. So our language will have prefix notation, like racket, but I will use curly braces to remind you that we're talking about a language for which we're writing an interpreter, not the language PLAI typed that we're using to implement this interpreter. In our language of arithmetic, we'll have plus expressions, and the evaluation of this is of course intended to be 2 plus 1 is 3. We'll have multiplication expressions, where we use an asterisk as usual to mean multiplication. 2 times 1 should be 2. And as you would expect, we can nest these expressions. So here plus is adding 2 to the result of 4 times 3. And that should be 24. This means that in general, plus and times take two expressions, not just two numbers. And the flip side of that is that since 2 is an argument to plus, 2 must be an expression. So numbers by themselves will also be expressions. If you evaluate a number, then you just get that number back. So the kind of expressions we have are either numbers, addition expressions, or multiplication expressions, where addition and multiplication have two expressions as their arguments. And that suggests that we represent expressions using a data type that has three cases, where the first case encapsulates a number, and the second and third cases encapsulate two other expressions. And that leads us right to this data type. Arith-C. The C stands for core for reasons that will become clear later, but this is a core language of arithmetic, where we have the number, the plus, and the multiply cases, where the num case has a number, and the left and right are each arithmetic expressions. What we're interested in writing is an interp function that takes an arithmetic expression and produces a result where a result is always a number. So we're going to be defining interp to take some arithmetic expression and produce a number. Let's write some examples. Let's go back to the example of 2 plus 1. How do we write that? We will want to interpret 2 plus 1 in concrete syntax, that is the syntax of the language we want to interpret. I might try to write that, but of course it's nonsense to write our little language in the middle of a PLA typed program. What we want to do instead is represent that using a plus C, where the 2 part is a num C of 2, and the 1 part is another num C of 1. So there in the box we have the representation of 2 plus 1 as a plus C expression with a 2 expression and a 1 expression. The interpretation of that should be 3. If you want a multiplication expression, it's similar, but using mult C, and still num C 1 and 2, and we get a 2 back. Note that I'm predicting a 2 back in my result, not a num C2. That's because our interpreter always produces number, and I can represent number results just with number. I don't need to use expressions or some other data type. Let's look at just 2 as an argument. What would that be? So the expression 2 we can't write like this, for the same reason we don't write curly brace plus 1, 2. Instead we need a num C, so that we have something of type expression. The result of that should just be 2. And I'm actually going to move this one back up so it matches the order of our data definition. And we covered all three cases. Just for good measure, I'll throw in an interp of a plus C of a mult C 2 times num C3. So that's 2 times 3 plus C of num C5 plus, let's see, num C8. So 13 plus 6, that should give me back 19. Those are my examples. I can move on to the template step, which is a type case of an arith-C, specifically the arith-C-A. It can either be a num C with a number inside, it can be a plus C with a left and a right, where we probably want to interpret the left, and we probably want to interpret the right. Or it can be a multi-C, left and right, where we probably want to interpret those. That's our template, and now we can finish implementing the function. If we have a number expression, then the number result is just that number. If we know the value of the left argument to a plus and we know the value of the right argument to the plus, then we just want to add them. And similarly for the multiply, we just want to multiply the results. Let's run our tests. Let's see, I have missed a closing paren somewhere. Try again. I'm still missing a closing parenthesis. And our test passed. So by following the design recipe, the interpreter is pretty well fallen out. We could explore some more down in the interactions window. I could interp plus C of num C. What kind of numbers do we get to write here, actually? We're relying on racket number data type, so actually I could write 1/2 and add that to 3 plus 4i, the complex number, and what I will get back out is 3/2 plus 4i, the complex number. If our goal then was to really understand how numbers are implemented and how arithmetic is implemented, then we haven't really learned anything because we've pushed it all into racket. We're just using racket's multiply and addition and its representation of numbers. Okay. When we do some other features of a programming language later, we want to be careful about that. In this case, though, we're just using arithmetic as a way of getting started, and we're not so interested in how the details of times and plus are implemented. So this will be okay.